Hey folks, welcome to Advent of Code in F#, day 5. The puzzle has unlocked for a while now. Let me plop up my screen, there we go. So I'm a bit late to the party today, and I had a sneak peek at the problem description, but that's as far as I went. So day 5, supply stacks, looks a bit like a Tower of Hanoi kind of problem. So we have stacks with disks or crates, sorry, and there's a crane that can move the top crate or the top, it can move the top crate from one stack to another, and that it happens one by one. So that is all clear. There's an example with 3 stacks in the problem description, and if I look at my own input, there's 9 stacks. First I was thinking, let's skip the parsing and let's just encode it into types, but now that I see this, I don't feel like it. Let's do some parsing. So I think that's a nice first step for today's problem. Parse the stacks. So as always, let's grab the example input and let's see if we can parse the example. I'm also going to grab my input, dump it into a file locally. There we go. And let's go to the example. Let's put that in here. Let's see if we can parse that. Is it correct that there's no... that's not correct. I'm gonna get rid of my trimming because trimming is not okay for what we're doing here. Is D the first column? No, D is not the first column. Where is this coming from? That's interesting. It's saying that D is the first character in my copied string buffer, but it's not. So I was not expecting to get stuck at this part. So yeah, it works if I new line. I have no idea what's happening, but anyway, there we go. I'm just gonna skip the first line. I don't really know what's happening, but I'm not gonna bother. I'm just gonna pretend everything is working. There we go. So this is our input. I split it into lines already, and that's how we're gonna get started. Let's take a look at the actual input, see if that is T the actual first crate. Yes, and then we have empty, and then we have Q. Yeah, makes sense. Yeah, that looks correct. Okay, so let's not worry about whether or not we copy pasted our input correctly. Let's start parsing. And let's start with the example first. How will we parse this? There's 2 blocks. Let's first focus on parsing the initial stack. One, 2, 3, 4. There's like 4 characters per stack or per column. Maybe let's do that. And let's start by splitting the instructions from the input. Yeah. So I'm just gonna grab every line until we hit that new line. That should be our... Yeah, that's correct. So I'm just gonna skip the 1, 2, 3. No, I'm not gonna skip the 1, 2, 3. Yeah, I'm gonna skip the 1, 2, 3 at the bottom. There's probably better ways to do this than reversing the entire list. But this works. Okay, so that's the stack we have to parse, and then instructions. And let's grab all the rest. So now we split our instructions from our initial stack. There we go. And now we can parse both. Let's work on the initial stack first. So I'm thinking there's lines, and every line is a level in the stacks. And if we chunk this into 4, we get the individual stacks. So let's see if that works. So I'm gonna grab whatever, the first row, just to get started. And let's see if we chunk this into sublists of 4. And it's a string, so it's a sequence of characters. And let's print it out. 1, 2, 3, 4. Yeah. 1, 2. So now we have the different stacks. Yep. Now we have the different stacks. And how can we parse a stack? If it's 4 empty spaces, there's nothing for that stack. And if there's these brackets with a character in between and trailing, then there's something in that stack. Sounds like an option? Yeah, sounds like an option. Let's go with that. So to parse the top row, yeah, every chunk, so every part of this list is a level of one of the stacks. So how do you do this again? I'm trying to pattern match. Yeah, this will work. Why is it squiggling? Yeah, okay, that's cool. So if we have this, like 4 empty or 4 spaces, we have nothing. This stack is empty. If we have this kind of construct, where this is the character, we have a character. And if we have, we will make an exception for the last one, that's only 3. So if it's 3 if it's 3 empties, that's our last column containing nothing. And if we have 2, what would it look like if it's the last 1, 2, 3? Just 1, 2, 3. So yeah, if we have like only 3 elements and it looks something like this, that's the exception for the last column. So then that's again sum C. Let me put the sums and the nones together. There we go. I think this parses a single row. None, sum D, none. That appears to be correct, right? None, sum D, none. Yeah. Okay, so this is our parse row. Or parse. Yeah, it's a parse, sure. And if we do initial let's call this rows. Oh, sorry. No, we need to chunk for every row, right? Yeah, so this has to happen inside the parse row. Every row we chunk it into 4 and we map. Yep, and let's list this thing to stay in the list world. There we go. So this should take a string and return a list of options of characters. Sure. I don't know why there's a 1 plus 2. Let's get rid of that. There we go. So there we go. DNC ZMP. DNC ZMP, that's correct. But now we have the rows, but we are more interested in the stacks themselves. I'm thinking maybe it was easier to just work with indexes, indexing at every column. But we've gone down this road, so let's continue down this road just for now. So we have our rows now in a somewhat parsed manner, and now we just need to transpose. Now we just need to transpose. I'm gonna do that by using an index. So I don't know if we gained something by this parsing into options. I don't think so, or not a lot. But okay, so let's use indexes now. I for I in parsed. Let's make that a list. And let's see what are we gonna do here. 0, 1, 2, 3. That's correct. No. Why is there 1, 2? Why is there 4 elements? Why is there? Oh no, there's only 3. Why do I get? Oh yeah, I need to do -1 if I do indexing. I use indexing not that often. As you can see, and it's a pretty bug prone thing, so yeah, that's better. So these are the initials we need to do something for. Can I grab the nth item? Item at index, yeah. So that gives me no, that's not what I'm doing. I need to map over every row. Let's call this the rows. What happened? Okay. Okay, there we go. So what do we need to do for every row? Grab the thing at that index, is that correct? Oh, it's too late for me to do these kinds of things. I think so. Let's see what this gives. None, some N, some Z. Some D, some C, some M. None, none, some P. That is correct. And we don't actually care about the nuns, right? We don't care at which level what is. If we just keep it as a stack. I made this way harder than it had to be. Yeah, I made this way harder than it had to be, but that's okay. Sometimes you have to come to these conclusions halfway. So that gets an element, and then what does this return? What's the type of this? A sec of a list of a sequence of options of characters. Oh boy. Let's keep everything in the same world. Everything is a list now. Yep. And now for every row. Let's get rid of the options. So NZ, DCM, MP. So we took a very roundabout way to parse our stacks, but I think these are our stacks. Would I do this again? No, I would just index, use this thing. Yeah, I would not go through the detour of using options. But we are where we are now, so let's go. So these are our stacks. There we go. Our stacks are okay. Yeah, our stacks are okay. So now let's parse our instructions. What do our instructions look like again? Move blub from blub to blub. Is it always a single digit? Our stacks are single digit and the number of... No, I can see move 22, 18. Let's use a regex. The time has come to introduce regexes. Let me grab a harder one. A harder one is something in the range of 10 plus, 20 plus. So let's grab this one. I'm gonna paste this one in the REPL so we can start. Let me include system.text dot regular expressions. Is this the pattern? Yeah, that's the pattern. So let's see if we can... I forgot about how the regex API works, so we're gonna have to look that up in a second. But I think if we do something like this, regex.match, it returns a match. So if we use our... No? What can you do with match? Yeah, it takes a string as input. Why is that not working? Okay, I was typing something else apparently. So that's a regular expression. If we run a match, success is true, so that matches. Okay. How do we say... how do we say multiple digits again? Well, what is the... I have this kind of a regex... What's the site again? Regex 101, is that the one? No, it was one where... Yeah, it could be one. What is it? Is it plus? Is it an asterisk? I'm looking for that kind of... Any single character, any single digit is this thing. So that's something we're going to need. That matches. How do you match on... How do you match on multiple digits? Plus. Plus matches between 1 and unlimited. So this is how you match on a number. I'm sorry for that. Had to look that up because I don't do regexes every day. So this should... That's always a single digit. This is always a single digit. Let's just encode that in. It's a success, and I think we have our groups or captures. Somewhere in there are the digits we just caught. There's a cool type provider. That was the term I was looking for. There's a cool type provider for F# that lets you have type safety when using captures and groups and regexes. But that's maybe a bit early in the advent of code to dive into type providers and stuff like that. Let's keep it simple for today. So, what's groups, what's captures again? I don't know the difference anymore. Let's see what's in here. No, captures? What's captures? I'm gonna have to look this up in a second. That's definitely not what we want. No. How do we capture stuff again? Was it this? We want to extract the digits or the numbers out of the match. It's been a while. Let's see if this works better. It's not a match anymore. What am I doing wrong? Maybe it's parentheses. That's a match again. Where are my matches? There we go. That's the 13. This is the thing we're looking for. Whew. We're gonna parse this thing by the end of the night. I have faith again. So. I'm gonna grab the value, parse it into an int. That's the amount. Let's call it number stacks. And let's extract a from and a to, or a source and a destination. From this to this. So that should be a 1. Yes, that should be a 3. Yes. Let's introduce a type. There we go. And if we have our parser return on those things, we're good to go. So this parses a single instruction. I know you can do something. Regex compile options. What is that again? Regex options. Not that it matters that much, but I've seen it used, and I think it's recent. Something recent, regex compiled. What does it do? It specifies that the regular expression is compiled to MSIL intermediate code instead of being interpreted. Sounds like it's a minor performance gain or major performance gain. So yeah, let's do that, sure. 1313, that's correct. So I'm gonna put this in a method. There we go. So that should still work. On the example, I'm just gonna inline it, and then let's drop that into a test, because that's something we might want to preserve for the future. That seems to work. So I'm gonna put that in a unit test. So parse instruction should be something with a number of stars. It's down here. So it should be something like this. And let's see if our auto formatter will help us. There we go. It did something all right. It did something all right. Okay, so we can parse instructions. Let's make sure that we can parse instructions. So we have instructions. Our last instruction in the example should be take 1 from 1 to 2. Is that correct? Yeah. Okay. I think we have everything. Let's grab parse row, let's tags, instructions. Where I lost track of where I am. Let's go over this thing again. So what is initial again? That's just our initials, those are our raw stack strings. This is the parsed rows, but that's something we don't really care about. The stacks thing is the thing we care about, right? Yeah, the stacks thing is the thing we care about. I'm just gonna put everything into a big old function. Yeah, and maybe let's keep that parse instruction separate because we have some tests for it, and I don't feel like rewriting the test to use the entire parse thing. Let's just keep it like this. So now we have a parse. It has stack instructions, and we can return something with the stacks and the instructions, but parsed instructions. Let's maybe parse them in this thing. There we go. There we go. That should do something. Something being parsing our entire thing. So we should get our stacks and we should get our instructions. That looks correct. I'm happy with this. Let's destructure so we have everything again. There we go. So now we can parse something. I'm unhappy with the one last thing, and it's I use example as the argument name. Let's call that lines or something like that. There we go. This was a somewhat heavy. Do I have a recording time? We're 26 minutes in, and I can parse my input. Good going. But I do think that the actual problem, once parsed, becomes less of a problem. Let's see if we're right here. So once we have our stacks and our instructions, we just need to run all the instructions on our stacks and at the end see what the top level crates are for each stack. So let's run the instructions on our stack. That sounds like a fold. That sounds like a fold. So let's look at the signature for fold again. Fold takes a function called a folder and some initial state and a list. Our list is our instructions because that's what we're going to be looping over. And our folder is apply instruction, a new function I'm gonna conjure into existence here. So there's and it takes stacks and an instruction. I'm not sure about the order of arguments, but we'll figure it out in a second. And it returns an updated stacks or an updated data structure. And then in our fold, we need the initial state, which is the initial stacks. It lines up automatically. Fold takes a state. So state is supposed to be the first argument of our folding function, which is apply instruction, and our state is stacks. Yes, this appears to be correct. So this is our skeleton, and now we just need to implement apply instruction. And our instructions are these things move this number of stacks from this stack to that stack. So how do we do that? How do we do that? Let's first identify the crates we're moving. I should be instruction. It does not know it's an instruction at this point in the code, so let's help our compiler. And it does not know what stacks is. Stacks is our list of a list of characters. Let's make that explicit. So we have a stack is a list of characters and stacks is a list of stack. And I'm gonna put those somewhere around our type definitions. There we go. So we have a stack, we have stacks, and we have instruction. Good enough. And our stacks here in our folding function is a stacks. So crates let's split our stack at the source. Yeah, so that was correct, I'm sorry. So this is the stack at the source, that's where we're taking crates from. And how many crates do we need to take? We can do a list.split at. And we need to take number of stacks, but split add is, oh, my brain. Split add is like array indexing, it's zero based, but this is. Do I need to do -1? That's what I'm trying to figure out here. So if we need to take one stack, so number of stacks is 1, we should split at 0, I think. Let's see if we have a list of 1, 2, 3. What does list split at 1 do? That looks correct, actually. If we split at 1, we take the first element into a... Yeah, that looks correct. We don't need to do -1 at all. This looks just what the doctor ordered. So we have crates to move and the rest of the crates in the source, and that's it. My mind is short-circuiting a bit, as in how do we update stacks? It's an immutable record type. We'll get there, one step at a time. So that's the crates we have to move, and we have to reverse those crates, because if we take 3 crates, we take the top one first, and it becomes the bottom one at the destination. So we have to reverse this, and then we can append the new crates onto stacks at destination. There we go. And I think that you can get rid of the dot for array indexing since one of the last versions. Yeah, there we go. Let's call it the new destination, and let's call it the rest of the source. So I think we changed the source and the destination correctly, but now we need to update the entire stacks. Yeah, not sure. My mind is blanking a bit. I'm gonna do a thing I learned in while using Elm. If you have like certain things you want to keep and certain elements in an array you want to keep and certain elements you want to remain unchanged, you can do a map, or map E means map using an index. So the function you get here has the index and the element. And this is the identity function, so it just returns the element. So this should return the stack just as it was, but now we can do if the index equals the source, we return the rest of the source. Else if is else if a keyword? I know there's an elif. Let's use what I know. So if it's the destination, then we do the new destination. And otherwise, in all other cases, we just leave the stacks untouched. So this is a very roundabout way of updating the stacks with these newly moved crates. If this works first try, I would be impressed. Or not impressed. Impressed is the wrong word. I'm not really working in small steps here, so... Oh, it doesn't even work. I'm doing some indexing wrong, probably. Source is, yes, this is 1 based, it has to be 0 based, I think. So if the destination is the first stack, yeah. Does it work with this then as well? I think. If index is -1, if source is 1, then we need to update the element at index 0. Yeah, so we need to do the off by 1 thing, or the 0 indexing there as well. If all went well, this should be the end result of the example after running all the instructions. Let's see if that is correct. We have a stack with C, that's correct. We have a stack with M, that's correct. And then we have Z and DP. That appears to work. So the stacks at the end of all instructions is this, and then we need to grab the top crate from every stack, right? So that's this thing, and for every thing we need to grab the first one, so that's a map. And we grab the first character, C, M, Z, and let's concatenate everything into a string. That's not a string. Oh, I don't even know what's happening here. String is the incorrect thing. I need to do a list.concat over here to append strings. No? I know it's a bit of a roundabout way of doing things, but string concat, is that a thing? String module has a concat function, and it takes a separator. There has to be a better way, but it works. It's been a long day. If I get my stars, I'm gonna allow some hacky code and some roundabout option-based parsing that was total overkill and irrelevant. But this looks correct for the example, at least. Dare I run this? Dare I run this on my inputs? I do. So let's write a new function called solve. Which parses the input and runs the instructions and then returns the string. And again, if we run this on... Oh, no, we need a solution. That's the thing we need, actually. And let's return solution. There we go. And if we call solve now, using the example, we should get the exact same thing. Yeah, looks correct. There we go. Solving the example still gives us CMZ. I'm gonna encode that in a test. My tests are not all over the place, but the way I don't understand how I make the decision to write something as a test versus just YOLO it. There's 2 tests in here. They seem to be completely arbitrary. I don't know what nudges me towards encoding something as a test versus just YOLOing it. But there we go. So let's solve for our input now. Oh no, that took a while. That's most often a bad sign for part 2 if it takes a while. Let's see how long it actually took. Is it only a second? Yeah, it's only a second, so it's bad, but it's not horribly bad. Let's see if part 1 is correct. Oh, that's the right answer. Okay, I'll take it. I'll take the win. Let's get ready for part 2 here. Copy paste my code. Still works. We can still solve it. So let's take a look at what part 2 offers us. This is new for me, so let's read together. As you watch the crane operator expertly rearrange the crates, you notice the process is not following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a crate mover 9001. Oh no! The crate mover 9001 is notable for many new and exciting features. Air conditioning, leather seats, an extra cup holding, and the ability to pick up and move multiple crates at once. Cool. So what changes? If we begin in the same configuration, moving a single crate behaves the same as before. However, the action of moving 3 crates means that those 3 crates stay in the same order. Oh, that's super easy for our solution at least. I think it's a one-line change. I love it. Yeah, so here we nibble off some stacks when we apply an instruction, and we just reverse that list. I think if we just stop reversing that list, there we go. We're done. Let's see this work on the example. That's an easy part too, if that's the case. I'm not even gonna read the example. I'm just gonna fire it off and see what it gives us. MCD. MCD is correct. That's awesome. Is it still taking a second? It's still taking a second. That's on the longish side of the spectrum, but I'll take it. And I have taken it. Cool. That was actually a very interesting and fun puzzle. If I were to do it again, I would not lose half an hour on parsing. And especially not on parsing with option types, but let's quickly go over what we did today. What did we do today? We used regular expressions, I think for the first time this month, or this year even. I introduced some types, but that's not new. We did that for previous days as well. So yeah, here's our regular expression we used. Played around with the compiled flag, or the compiled option. That's supposedly to parse better or to improve performance, but for our input it's probably negligible. I did a lot of somewhat frowned upon things in my head, reversing lists, skipping, reversing lists. There's probably a way more elegant way to do this, but let's not worry about that. We got it parsed in the end, and that's what matters. This list choose.id idiom, that's if you have a list of options and you only want to keep the sum values, that's a cool trick to, because if you look at what this thing does, it choose, applies a function to each element in a list and then returns a list of values v where the applied function returns sum v. So if you pipe at the id function, you just get rid of the option container. But that's a detail. The most interesting part today, I don't know if we've seen it this month, but the most interesting part for me at least was this folding. That's something I use for a lot of problems. If you have an array of instructions, say, and you have some initial state and you want to apply every instruction and have it update the state, that's what fold was made for. Also interesting, or also something I like, is this update an array, and if you have to update only certain elements in the array, you can use this trick, like map over every element, and if the index is an interesting index you want to update, you can provide a new value and otherwise just fall through to the original value. That's something you see a lot in Elm code, for example. I think that's it, and there's a really roundabout way of getting my string out in the end. So, am I very proud of this code? No, but did we get our stars and have fun? Absolutely. So yeah, I'm gonna leave it at that. I'm not gonna clean up. I'm in it for the long run this year, not for the perfect lines of codes. I'm just getting my stars and getting out of there. I hope you enjoyed the stream, and I will see you tomorrow on Advent of Code in F#. Bye-bye.